Welcome everybody to this, the 16th of my weekly presentations. This week I will be covering the restoration of a Shaku Dokei, literally translated to scale clock, the scale being the vertical indication of the hours. It's a Japanese stick clock or pillar clock if you're looking for them on the internet or on sales. Here are a few variations of the case style and the indicator dial layout. These are from a museum. I think it's fair to say that the Japanese of the Edo period were the originators of open plan living. Here is a view of a typical Japanese home, the roof supported by pillars throughout the house instead of walls. Any dividers were simply made of rice paper. Here is a pillar clock in its correct position within the house. In late 2016, I purchased an 1800s Japanese pillar clock to add to my wall weight-driven clock collection. Typically, it was a basket case, but it had the remnants of a rosewood case. It was a 1 foot long or tall model with the calibration scale below the mechanism. It was weight driven with a verge escapement and horizontal balance, and the falling weight carried the hour indicator down the pillar past the hour markers to indicate the time. Here you can see the extent of the damage to the item that I purchased. The case was in pieces. All the hour indicators were there, but the pallets, the pallet arbor, the balance and the hairspring were all missing. But the pillars and the front plate were beautifully made and beautifully engraved and had lots of potential for restoration. A very basic movement, time only, but finally made simply by dismantling, cleaning, polishing and lacquering. The true beauty of the Japanese workmanship is revealed. These pillar clocks are weight driven, and the weight to drive the clock hangs from the great wheel cable drum and passes down inside the case behind the hour indicators. The most important parts that were missing were the balance spring and the pallet arbor. So with research on other clocks of the same type, I was able to design and construct the missing pieces. Here is the brass balance made from a solid single piece of brass with the spokes fettled at their ends to enhance the appearance of the disc in a typical Japanese way. Now for the tricky part. There was no balance spring fitted to this clock. I didn't know what the rate would be, or could be, or should be. This clock is different to any other clock in that the falling weight carries an indicator to point to the time. So instead of having hands, the falling weight and the amount of cable on the drum are basically components of the time train. By inserting those particular parameters plus the normal wheel count, my Excel spreadsheet gave me a beat rate of 6,287 beats per hour. and that I was able to use as a target for the construction of a balance spring. Armed with the beat rate for the movement, I now move to the physical constraints to fit a balance spring within the top of the movement. The original pinning stud was in place, and with my pallet arbor also now in place, I can see the available space for 4 coils, which is typical of these movements. With those 2 dimensions of the outer circumference and the collet mounting, I made a small template in full size so that I would be able to coil up any material that I thought suitable to make a balance spring. Where do you start? First, I found an Omega watch spring. I didn't know what it was from. It was just a loose spring. I coiled it up and it was far too strong. So it was back to the drawing board. What could I use? And then a light came on. What better than a roller bar suspension spring made from a material that is not affected by temperature. A roller bar also make an amazing range of gauges so that it's possible to choose between 2 thou and 6 thou. I tried 2 thou, coiled it up, put it into the clock, and had a rate of 4006. Too slow. I coiled up a 4 thou, 7,583 beats. Too fast. I coiled up 3 thou, just too slow, at 5,308 against my target of 6,287. So my target fell somewhere between 3 thou and 4 thou. The beauty of the Horolovar 400-day clock suspension springs is that they go up in gauge by half a thou. When I graphed my 3 points of 2 thou, 3 thou and 4 thou, they developed a very nice curve. When I looked at their 3.5 thou spring on my graph, that coincided with 6,245 beats per hour, extremely close to my target of 6,287, only 40 beats per hour different, and I'm sure that would be within the range of the regulator on the clock. The Horolovar suspension spring was perfect. At 3.5 thou and coiled up to the 4 coils, when pinned and passing through the regulator, I was able to attain good timekeeping. The regulator is shown through this very nice little slot in the front of the containing drum. On the front of the movement, there's a little hand that rotates, and you would think that would be indicating time, perhaps even seconds, but no, it's purely a running indicator. It has no timekeeping function except to let you know that the clock is actually running. The case parts that came with the kit, I cleaned and reassembled, glued them back into place, fitted the movement, then treated all the timber with tung oil to bring out the colour and the depth of the rosewood, silvered the hour markers and polished and lacquered the brass adjusting scale down the side of the markers. It didn't look too bad, but still something was missing. The little key drawer at the bottom of the clock was missing, so I purchased some rosewood from a supplier in Mulgrave in Western Sydney. and made up the little drawer to fit into the space available at the bottom of the clock. Also missing was the glazed hood. Using the same rosewood that I purchased for the drawer, I designed and constructed a small 3-glass hood. The glass had to be 1mm, and this I found in a picture frame in Woolworths. I had my falling weight, a block of lead, and normally the indicator is on the end of a pin which is driven into the lead block. So as the lead block falls, the indicator follows down and points towards the respective hour. There are 2 clocks in the reference books that show that this indicator is a little tortoise, and I thought I will have a tortoise. So you can see my interpretation of a tortoise attached to the lead block, sliding down and indicating the time. These pillar clocks have a 24-hour dial, and each of the time markers are at 2-hourly intervals. So the dial has 13 markers going from 6 AM to 6 AM. And that completed the restoration of this beautiful little clock. You can see from basket case to a lovely little wall clock. Thanks for watching this presentation. I hope there was something of interest in this talk, and maybe you will find one of these little clocks needing some love and care and attention. I can't believe it's 4 months now since I started giving these presentations, and in all that time we've had to keep ourselves safe and well by isolating. I hope I've in some way helped you through that period. If you have any questions or comments to make about this presentation, you can send me an email to the address shown at the bottom of this page. Thank you very much.